Hello, everybody. My name is Chris Toomey, with Solution Architecture Lead at Mapbox, and I'd like to welcome you today to the webinar on Modernizing Logistics, how to program an asset tracking architecture using serverless technologies. We have a really great webinar for you today. I'm joined by my two esteemed colleagues here in Seattle, Trevor Hansen from AWS and Cameron Stokes from Pulumi. So without further ado, I'll let them introduce themselves when we get to them. But we wanted to quickly cover what we're going to talk about today. First off, we're going to go into the concept of asset tracking and the fundamental architecture that we built at Mapbox. We're going to talk about best practices and thinking about how to build this in a serverless way using modern application techniques, how that can modernize logistics by taking advantage of real-time location data and analytics. We'll talk about how we build this type of application with using Pulumi technology. Trevor will cover some core concepts in AWS, and then we're going to bring it back to a real-world example of the race across America, which is a literal bike race across America, where this technology is in use as of right now. And we'll peek into the race and see how things are going. But first, to set the stage, when we think about the world today, we actually spend a lot of time, both as individuals and as companies, tracking things, where everything from where are my laptops to where are my trucks, where's my kid, where's my dog. This location information is everywhere, and we use it probably without thinking too much to make day-to-day business decisions. Knowing where these things are and how they move around the world helps us optimize our lives and optimize our business. And just as a quick fact, to start things off, this location data is generated in the volume of about 125 libraries of Congress every day, which is massive. Like, this is a massive amount of information that is waiting to be captured, waiting to be acted upon. And we talk about logistics, but we're not really specifically speaking about moving like freight or your Amazon Prime deliveries. We're talking about just the movement of things around the world. So what's the challenge here? We've talked about the scale of data, but what really comes down to is whether it's your dog or your fleet or your wallet, which I seem to lose almost every day. The problem is really the same. If we think about these types of solutions and these types of architectures previously, what happens is you would buy from a vendor, you would be locked into them for a couple of years and probably a lot of money. You'd have slow product roadmaps. You don't own your own data. You generate it, but it transits their systems. And when that happens, we see things like this example from Twitter, where somebody has been using location services on their phone and Google has captured it. A lot of companies do this. They capture this information. They're using it to improve their maps and other things like that. But you don't own that pipeline. Someone else does. And we believe, both Mapbox and AWS and Pulumi, that modern applications today start from security and privacy and control as a first principle. You shouldn't have to sacrifice any of that to achieve scale and business outcomes. Using someone's product shouldn't mean giving them access to your data. So what we really want is a new way, something that's really straightforward, that's easy to build, that's easy to scale, and is private and secure out of the box. So Mapbox has teamed up with Pulumi to build an architecture that does this out of the box for you. We call it the Mapbox Asset Tracking Architecture. Here's a quick look at the general techniques and the flow of data. It's an end-to-end serverless system that allows you to ingest, process, archive, and then query your data at any scale. We've designed it to be modular and flexible, so if there's a piece of technology that you tend to prefer, swap it out. This also isn't just a picture, and it's pretty and it's great, but it's actually real. This is something that works. It scales. We're using it in a production environment right now, and because we wrote it with Pulumi, this makes it very easy for us to share it, to fork it, to try different versions, to adapt it to different use cases, different clouds, without having to sacrifice kind of our core technical and business needs. So later in the webinar, we're going to share this use case with you, the race across America. But next up, I'm going to hand it over to Trevor Hansen of AWS to talk about modern application development with serverless to kind of set the stage technically. Trevor, off to you.
Excellent, thanks, Chris. So hi everyone, I'm Trevor Hansen. I'm a partner solution architect with Amazon Web Services. Just to give you a bit of a background, I've been with Amazon for just closing 4 years now. I've worked all the way from companies doing that whole lift and shift migration, really looking at what benefits does the cloud provide, all the way through to working with some very early stage startup, and now I found my passion working with VC-backs in the partner space. So really looking at what tooling and functionalities out there, and working very closely. So I'm very fortunate to be working with the two parts on this webinar today, with Pulumi and with Mapbox. Be excited to hear that journey that they've really been working on, providing tooling and functionality to solve certain cases, for you guys to be able to achieve things. So what I'm going to be doing today is just sort of setting the foundation of, the cloud has really enabled a lot of, amazing things to start happening. And you're really seeing this whole digital transformation happening. And we're really seeing this notion of, modern application development and what this is. So when you're looking at moving into using cloud services and tooling and so on, you really want to start looking and adapting to certain application development types in the cloud that sort of drive you to be able to move a lot faster and you get those benefits. What you do see is, people are moving into the cloud and they're bringing old habits, and it just becomes time consuming and so on. When you move towards abstraction and modern application development concepts, you're really starting to look at, what functions and services and tooling can help you able to move faster so that you can kind of focus on, core business components instead of focusing on these undifferentiated heavy lifting things, focusing on, maintaining architecture or serverless, sort of the underlying components that's supporting that. You can really start looking at, using things that are abstracted that allow you to move quicker and so on. But we'll unpack that. So, one thing that, every company is focused on is improving that sort of customer experience. And if you do have a really good sort of tooling landscape and sort of application development framework that your teams are adapting, you really want to be able to iterate really quickly on those applications. And, I'm really passionate about, the whole DevOps movements and now how serverless has started making things even a lot faster and a lot easier for you to be able to try new things, and be able to put it out there and get the feedback that you want. And Pulumi's done a phenomenal job in creating this abstraction, and really allowing your developers to focus on that customer experience aspect instead of having to deal with that underlying, the pain points and the time-consuming things that kind of slow business down. Businesses nowadays starting to adopt these things are able to be a lot more competitive because they're releasing new features and really giving the customers what they want in any particular application workload. So to kind of frame, that journey, on the left-hand side, I can imagine you're all too familiar with what modern application has brought compared to this monolithic applications that traditionally we used to have. So, companies that had a piece of software and they've grown over a period of time, you have this snowball effect of adding on things and eventually getting to this monolithic application that's, it's very sensitive to change, and, it eventually starts slowing down the company, and it becomes, one or two people in the company understand it end to end, and things just, the blast radius is really bad. It's not a position that you want to be in, especially if you want to continue growing your company. And nowadays, when we start looking at, being able to take those applications, you're breaking it up, you're decoupling it, you're starting to look at how you can achieve things using microservices and allowing sort of teams to focus on how they can serve their particular area using a particular application instead of having to have everything fall under one big monolithic application. And we'll be unpacking a little bit that shortly. So for you guys that you may already have serverless some background, and everyone's in a different journey in this, in a different step or phase. But at a very high level, you really want to look at serverless in these kind of concepts is, you don't want to ever have to be managing underlying infrastructure or services that support those workloads. You really want to be making sure that, patching and those things are handled by the underlying serverless architectures. You really want to be able to have sort of scalability based on use. So, let's say you have an amazing marketing campaign or you've expanded your application globally. You really want to be able to have that application scale without you having to go and deal with all those things where you have to come up with the mechanics to make that scale. So scalability should be baked in by default. And this is what we've really done, for our serverless apps that AWS has been working on, and we're continuously pushing to improve those. A big change in this modern application development is, no longer looking at licensing lock-in. You're really looking at how to pay only for usage. So, if you have, X amount of customers on your application or platform, or whatever the load is at a particular time, you really want to be paying exactly what you're using. So you're moving towards sort of these abstracted applications that don't have long running times, and also you're not having to pay for idle time. And then, high availability and redundancy should be baked in. That fault tolerance is really crucial. You don't want to be woken up in the middle of the night. And, serverless sort of services are really allowing us to be able to move to that where these service teams are taking those responsibilities and allow you to focus on that core business. So, this slide I could spend, a fair amount of time on, but I want to look at this at a high level. When we look at the serverless development lifecycle, you're looking at a couple of different phases here. And that first phase is, really trying to prototype and understand, all of us are learning at different paces. We're getting, we first heard serverless being a buzzword. We started seeing a couple of webinars or blogs or self-paced workshops. In this case, you've stood up something in serverless. Maybe it's like, a Hello World application or an Alexa skill or something that basically shows you what's the benefits and how quickly things stand up. Pulumi spends a lot of time busy working in this area and helping you be able to easily prototype and put together that POC. In this case, Mapbox really wanting to figure out how we can be able to serve our customers better, faster, and, be able to iterate. They, went through that cycle, they established their use case, and then they started looking at moving to that next phase is how can I start developing and iterating? There's a lot of different really cool tools in the space. We have the serverless application framework that can, has a local CLI, but also you being able to have, local iterating on that application and local testing. So it kind of ties into your traditional development workflow that you'd normally have. And once you've established your, that application is ready to be pushed out into production, that deploy phase can come through, continuous integration in multiple different ways. And this is something that, there's a lot of different tools out there from, code build to code pipeline and also other services that can help you be able to stand applications up, get those artifacts and ready for production. And then the last component is crucial point I want to touch on is this monitoring. Once you've got an application out in production in some capacity, serverless really starts, breaking things up and you have a lot of different moving parts. You really want to empower this last component with end-to-end visibility and also be able to have visibility and pinpoint problems if there's any production pains and getting people to focus in. Each of these steps kind of, with the right tooling in place, can allow your developers to really focus on moving very quickly, and serverless, by no doubt, helps that drive. So the last thing I want to cover is sort of these 3 best practices that sort of we recommend you starting off with. There's many more that you could add on. And Pulumi is really going to showcase, this first one, which is moving to modern application development. You really want to look at going towards infrastructure as code. You're able to define this underlying architecture that's going to be supporting your workload in a template. Being able to have something where you have this template that you can deploy to provision architecture. It's a repeatable template. It's got version control baked in. And it really allows you to be able to tie it into, how you actually do code reviews and processing to get things out there. Infrastructure as code, such as CloudFormation and our serverless application model, and partner tooling like Pulumi that really takes that abstraction for you to a whole new level. I highly recommend taking a look at that and seeing how those things happen. The next is, you really want to set up automated deployments. When you start looking at building out applications, you're scaling that application workload, you really want to have those things in place because it's really time consuming to have to manually go through each of those steps. You really want that release cycle to be as automated as much as possible. And then the last is, I touched a bit on this, is that monitoring and observability. That is something that you really, when you start breaking things up and you're building out these microservices applications, you really want to have the right tools in place to help you understand how your customer experiences over a period of time, but also being able to dive deep very quickly. So I'm really excited to kind of showcase, these amazing partners that I work with and what they've been doing for their customers. So I'm over for you guys to kind of unpack that. And I look forward to if you guys do have any questions. And let me know if you have any anything that you would like to do. Please reach out. I'm happy to help you guys. So that's it from my side.
Hey everybody, my name is Cameron Stokes with Pulumi. As a quick background, Pulumi is an infrastructure as code and cloud automation tooling company here in Seattle. My role here is customer engineer, so I work with our open source community as well as our customers to be successful with Pulumi and do evaluations and trials and build complex architectures in a simple manner with Pulumi. So as background, I'll talk briefly about what is infrastructure as code to try to set the stage for that, for those that might not be familiar with that. And the idea of infrastructure as code is to bring automation and eliminate manual configuration steps for building cloud applications on Amazon and on other providers as well. And really what we're doing is bringing software best practices to infrastructure management. So all of the best practices that we've been building applications using for decades now, so testing, code review, version controlling and such, bringing that to your cloud applications, your infrastructure. And that's providing visibility of changes through those code reviews, through previews, so that you get just higher quality and more rapid iteration to build and deploy your applications. And more around the why. So again, eliminating those manual configuration steps in the Amazon console as an example. Using infrastructure as code, you bring automation and repeatability to your deployments. So that gives you greater confidence that you're delivering quality configurations and quality applications, and you're less likely to make an error by doing that manually. We're also decreasing time to market for new applications and making changes to existing applications using automation as well. And then I mentioned it briefly already, but all this leads to safer, more predictable changes in making infrastructure changes to Amazon resources and then other provider resources as well. Again, because you're less likely to make an error by clicking through a console essentially. So more concretely, what is Pulumi? Pulumi is a platform, as we call it. But it's an SDK, so it's a command line tool. It's a set of open source libraries and SDKs for working with the various providers that we support. We also support general purpose languages, which is really a big value part of Pulumi that I'll get to in a bit. We also have a SaaS platform, so it brings team collaboration features to infrastructure management, supports CI/CD integration, code reviews, access controls, role-based access controls and such. All of that is provided through the Pulumi SaaS as well. Pulumi fits really all use cases and all types of modern applications that can be deployed to the cloud. So that includes containers. So we have really fantastic support for all the container types and services that Amazon has, including EKS, ECS, Fargate, and so on. We support kind of your more traditional infrastructure applications, so EC2 virtual machines, load balancers, VPCs and such, so kind of more traditional apps. Kubernetes, I mentioned a bit already, but really great support for EKS in terms of provisioning EKS and all the kind of surrounding resources such as IAM and such that you need to provision at the same time. And then serverless, as Trevor mentioned, is a really fantastic use case for Pulumi as well, where we have really great support for building and deploying Lambda functions, as well as integrating those with all the various other services that Lambda integrates with Amazon. So Pulumi is not focused on just one of these use cases. We have really great support across all of them to support all application types, essentially. To talk a bit more about the SDK, so we kind of have a few different layers within the SDK. Kind of at the bottom of this graphic is our foundation providers, as we call them. So that includes Amazon as well as other cloud providers, but also service providers as well, such as New Relic, VMware, and again, Kubernetes is an additional provider we have, as well as other SaaS providers that you can compose and use together within a Pulumi application. Then above that, we have a set of productivity libraries that help, again, kind of give you a better experience using or deploying serverless or container applications. And then just this week, we announced and released Pulumi Crosswalk. I'll talk a bit more about this in a bit, but this is a set of open source libraries that actually let you build applications on Amazon that have best practices automatically or that come built into that library. So you get kind of best of breed, best practice deployments to Amazon without having to do kind of all the heavy lifting yourself. An important aspect of Pulumi is that you do not have to instruct every single step that you want your Pulumi application to do in order to build your infrastructure as code and environment, essentially. So really what you do is you define in your code the final state or the desired state of your cloud resources or your Amazon resources. And Pulumi knows all the API operations and the order of those operations that have to be executed in order to construct that. So if you're familiar with using some of the other developer tools out there, such as command line tools with Amazon, you have to be very, very procedural or imperative in terms of how you construct your environment. With Pulumi, again, you define that desired state, and Pulumi knows all the different, again, API operations to achieve that. So it's really a nice, quick way to define those cloud environments that you have without having to know all the ins and outs of the different API operations. An important feature of Pulumi, again, is that we support real programming languages and general purpose programming languages. So we support JavaScript, TypeScript, Python, and Go. This allows you to construct your Pulumi applications in any of those languages using the SDKs that we provide for the various providers. So you're not using YAML, you're not using JSON, you're not using another configuration language to define your infrastructure. You're using actual programming languages that you probably are already familiar with and already are in use at your companies. And the value in this, it might seem simple, but you're able to use conditionals and loops and kind of all of the features of the language and the ecosystem of that language to construct your application. This is really quite valuable for large and complex cloud architectures, which many of the modern applications that we're building are, where you might need to change parameters or values of them, depending on environment, depending on a region and such. All that's really easily achievable using general purpose languages with Pulumi. You're also able to compose multiple provider types and resources within a single Pulumi application. So in this example on the slide, we're using the AWS provider that we have, as well as the Kubernetes provider, to create a cluster and then deploy services and such into that cluster, referencing an S3 bucket, all within a single application. So you don't have to manage one provider's set of resources with one tool and a different provider's resources with their tool or a different tool. Pulumi gives you a single tool and a single workflow to use across multiple providers and multiple services. So I mentioned a bit about Pulumi Crosswalk for AWS already. Again, this was released just this week, or announced just this week. In this example, we're using the AWS X package, which is a part of Pulumi Crosswalk, which again lets us build Amazon resources using much less lines of code that we have to write with best practices and sane defaults and such automatically built in to these packages. So we're kind of taking the well-architected best practice documents and such that Amazon's published and building them into creating an ECS cluster, assigning EOBs or application load balancers to services, building Fargate services, VPCs, and so on that have, again, all those best practices built in. So it really is the the fastest and easiest way to deploy well-architected applications and architectures on Amazon using Pulumi Crosswalk for AWS. As a part of the Pulumi SaaS, again, the service that we have, we give you end-to-end visibility of your changes, so you can track your deployments from source control commit, a git commit, to deploying that and provisioning and managing that infrastructure on Amazon. So you're able to see the full history of who did what and when, track changes back to, again, that git commit, so you can correlate changes in behavior in application, changes in performance and such, without having to guess what changed and what time did something change. Again, all that's provided through the Pulumi SaaS. We have webhook support, integrations with Slack and other systems, so you can push infrastructure events based on your Pulumi deployments into third-party systems or third-party services that you're using. So chat ops is a very popular idea and topic in the industry right now, which is bringing visibility of changes into your Slack and your chat systems, so that, again, everybody on the team knows who changed what and when, and again, correlate that to other events in your application or in your environments. We give you a really great dependency parent-child visualization within the service as well, so you can actually see how resources are related to each other in your application as you deploy and manage them. And it's really a nice way if you're a developer and engineer that's working on lots of different projects in your company and kind of switching between different environments and regions and such. This is a great way to get a nice quick view of kind of the complexity of the project that you've kind of just jumped into. Again, if you're switching projects a good bit. And again, you're able to understand in this visual that you might have a bucket that has Lambda functions that depend on it in order to do event notifications based on object puts, as an example. Subnets are related to VPCs. You'll see that as a dependency within this visualization as well. And I'm not able to show it in this slide, but this is a dynamic view. So you can actually click into these objects and zoom in and zoom out to get a kind of a broader view of the environment that you're within as well. The Pulumi SaaS also brings role-based access controls to your infrastructure environments as well. So a really common practice that we see is that developers might have, kind of free and unfettered access to their developer environments. They can spin up resources quite quickly, tear them down quickly to iterate on changes that they're making. But for staging, for prod, for kind of your more critical shared environments, certainly prod, you might want tighter controls over who can do what. And with the role-based access controls within the Pulumi SaaS, you can allow your developers, again, to iterate quickly within dev, but then force changes or encourage changes to go through your continuous delivery pipelines by just ensuring that they don't have write access, essentially, to prod or to staging or QA, and that your CD pipeline is the only tool or only stage that has write access to prod, as an example. So again, just instilling best practices in environment management and infrastructure management into your engineering teams. So to wrap it up, Pulumi brings a lot of valuable practices to infrastructure management and application deployments across Amazon and then other providers as well. For developers, you're able to use languages that you're likely already familiar with, you're comfortable with. You're able to use your favorite IDEs to develop Pulumi applications in those languages. You get auto-completion, IntelliSense, all of the great values that the IDEs bring. And then the full ecosystem of those languages as well. So again, for JavaScript and TypeScript applications, you can publish your own Node libraries or Node modules that you want to reuse across projects within your company. You can pull in existing Node libraries to bring in functions and such that you need to use to incorporate into your applications. And you can use, again, real software engineering practices like unit testing your infrastructure applications with Pulumi, and again, packaging and again, the full ecosystem that those languages provide. For those that are DevOps engineers or SREs, you get a single tool, a single workflow to use across clouds and different providers. So again, you don't have to learn separate tools depending on which provider you're using. You get all the benefits of infrastructure as code, so continuous delivery, code reviews, auditing, policies, role-based access controls, all that is provided with Pulumi as well as the SaaS. And you're able to enable your developers, your application developers and such, to iterate quickly, but providing them guardrails and providing them a smooth path to production, essentially, with all the features of Pulumi and a CD integration and such. And then for the technology and business leaders out there, Pulumi really enables your engineering team to modernize their infrastructure and cloud application practices using Pulumi. You gain visibility into changes within your environments, and you're able to see how consistent and rather encourage consistency across environments using Pulumi as well. Your developers are more productive because they're using languages and tools that they're familiar with, and they're using a single tool across providers. And you can build consistency again into those environments using building reusable modules and best practices with Pulumi as well. So with that, I will hand it back to Chris.
Thanks, Cameron and Trevor. That was a really great introduction into best practices and how you can actually apply them into day-to-day applications of any scale, of any provider. So this is, I think, a really great transition into how we how we can actually build things. So let's actually build something. So at the beginning, I mentioned that we have this asset tracking framework, and it was this pretty picture. But I really want to talk everybody through a use case, something that's real, that's tangible. So what you see on screen is a map. It's not a Mapbox map, but it's a map, and a bike rider by the name of Dave Hazy. I know we prefaced this entire presentation around logistics, where people are thinking about UPS or Uber or Instacart. But if we go back to our core problem, those are just questions of scale. It's the same thing of I have things and they need to move around the world. And how do we coordinate the movement of those things? So bringing it back to Earth, we were approached with an opportunity to partner and sponsor this rider, Dave Hazy, who is a world-class cyclist in competing in the race across America. So for those of you who don't know what it is, it's a bike race from Carlsbad, California to Baltimore, Maryland. Some people do it in teams, kind of like the Ragnar Relay, and others, like Dave, do it by themselves. And he's done it about 6 times. The last 2 years, he's come in second. And Team Hazy is actually using this asset tracking infrastructure to help track Dave, keep him safe on the course, track a huge number of performance and biometrics to help him be optimal. One of the things that we're tracking is based on weather and speed and elevation. How much does it cost for him to sleep? And this is a really long bike race. He's planning on getting it done in about 9 days. He's going to sleep 7 times for about 2 hours apiece. So picking when he sleeps and how much he's going to recover and how much effort he's going to have to expend is a really important thing. We also want to make sure he doesn't overheat, he gets enough food and all of those different things. And the goal here is that we believe as a team that combining all of this data and all of this activity and analysis, we can get him to the finish line faster and more efficiently and safer than anybody else. So the challenge is not small. We have a number of different sources. We have a watch, we have a Garmin, we have a number of different sensors. He has an equivocal piece of a sensor that sits around his chest that's covering, and he also has taken a pill that monitors his internal temperature, which I guess is a thing. I didn't really know that. But this data needs to be captured and easily accessible, combined with external data for ML and other analysis. It also has to be scalable and economical. We need to be able to expose it to a UI, and we need to have it work. And so going back to the notion of serverless technologies and paying for what you use and not managing underlying infrastructure, this is a perfect example of how we can attack this problem. So we've updated our solution a little bit to account for some changes. The architecture at the beginning is a general approach, like ingestion, processing, backend, query. So because we started with Pulumi and having these general programming languages and the expressiveness of their SDK, we're able to iterate quickly. And I'll walk through all of the code shortly, show you how it's being used in production, as well as like the website, so you can track Dave yourself. We moved away from API Gateway to IoT Core. We wanted that scale. that IoT Core provides. We also upgraded our Lambda function to make it schema agnostic. We didn't want to be prescriptive in the data that we send. We also can't predict how the data from the watch or the other pieces of infrastructure are going to send. So if they're going to send a null, we need to be able to capture it. If something fails, which it did on the first day, we lost our watch for most of the day. We need to be able to capture that and not be constantly updating our schemas. We also altered Dynamo to be more time series oriented, so we can have really great visualization. We've also added some app sync connections so that we can have a modern front end as well as real-time subscriptions. And then we also, by hand, forgive me, we add a rule to IoT analytics. We have a number of statisticians who are querying this data and using it to populate time cost of rest, time cost of weather, time cost of elevation models, so that we can help Dave get across the finish line. So this diagram is helpful, and we've talked a lot about abstractions and these sorts of things, but let's actually look at something. We're going to look at the original architecture, walk through bits and pieces of it, talk about why we did that, and then we'll show you the actual production. We'll deploy it, and then I'll show you how it's being used, as well as getting into the Pulumi console so you can actually see the whole end-to-end developer experience. So I may ask Cameron to comment on some of the things that we're doing as we're making changes to this code. We'll showcase the AWS Crosswalk because it is a fantastic library. So with that, I'm going to switch it over to the demo. So just bear with me while I share my screen. Cool. We should probably see we see this asset. Hopefully, we see the asset tracking stack inside of Pulumi. I'm going to switch over to my code editor. I'm a big fan of VS Code. And this is it. This is the original one. So we can see that this is JavaScript. I haven't adopted TypeScript. I just haven't taught myself to use it quite yet. And the beauty of this approach, these general purpose languages, is we can write code we're comfortable in. Mapbox, as part of our global platform, where we write a lot of Node, we write a lot of C++, we do write some Python, but this is a language we're all comfortable in. We can see we're just bringing in requirements, we're building some things. Here, this is an abstraction called the Cloud Framework, where we're able to quickly build an API that allows us to access Dynamo, and that Dynamo table is created here with a partition on an ID field. We can then, the beauty of Pulumi is that we don't have to think too hard about how things are going. We can just find the opportunity to insert our code and our functionality. So here we're saying when we fire a get against our endpoint, that request is going to trigger a table scan. And then we're going to build some GeoJSON on the fly to allow us to paint dots on a map. Now, this is the correct function, and then you've probably written this if you've used our turf library before. But what's beautiful about this is I don't have to worry about packaging. This is just saying, go get the features. I'm writing regular JavaScript code, parse it, use the turf.point to turn it into a feature, and then use turf.featureCollection to turn it into a GeoJSON FC, and then fire that back to the client. I don't have to worry about dependencies. These magical functions really allow us to work quickly, and we can iterate on this very quickly. Again, we talk about best practice. We talk about security. We're building all of these IAM policies that are tightly scoped, allowing us to assume roles. This one's not so tightly scoped because this is more generic. We're building a Kinesis stream. We have this API gateway to bring the data into Kinesis. I mean, the Swagger spec's a little verbose, but it allows you full control over your infrastructure. And the beauty of this is that we can just be specific about, let's grab the ARN, let's grab the region, let's grab the name or the ID or the ARN of whatever our pieces go. And Pulumi manages all of these dependencies for us. There's how to build. We're building an API to ingest this data. So we have our API gateway. We build the deployment stage, and so we're kind of building out this whole infrastructure as we go. And then we come to probably my favorite part, which is the Lambda function. So here, this is it. We have an external Lambda function is written in JavaScript. This is what we call the Mapbox stream processor. This allows us to take in data from Kinesis. We can have as many shards as we want. We can set how many, however big the batch is. We can set our partitions, and we can scale this up and down however we want. We have it externally here because we needed to do some lookups. And at the time we wrote this, Pulumi hadn't deployed their fantastic output captures yet. And so, if you decide you want to write everything in JavaScript, and if you want to write your functions in line, that's great. You can do that. Here you can say, pick your runtime. You want Go, you want C++, you want .NET, whatever. You can just write it. Pick your ARN, and we just package it up. Now, this is the same thing that happens if you want to use ECS or Fargate. You can just turn this into Docker with a Docker container and pump that back up. So this is a quick and dirty introduction to the core infrastructure. So let's switch over to the real one, and I'll show you some of the magic that Pulumi's allowed us to work. Can't remember all of my branches, so we'll just quickly take a look. Cameron, while I'm switching over, would you mind quickly touching on the concept of a magic function?
Yeah, so I touched briefly on this in my slides, but Pulumi supports serverless, but supports Lambda functions, and essentially allows you to define and write the resources that your function is integrating with alongside the function itself. So you don't have to have, again, a separate process for creating those resources, such as S3 buckets or DynamoDB and such, and then have a separate process for building and deploying and provisioning that Lambda function. Pulumi lets you define that all within a single application, and Pulumi handles all of the extra steps to, again, package up that function and package up that application into a magic function, essentially, that again kind of eliminates those manual steps and then publishes it to Lambda, really in kind of a one-step publish, essentially, that you don't really have to worry about the complexities of doing that.
Yeah, it's fantastic. It's saved my bacon multiple times. It literally is magic. So I for one, appreciate the ease of use. So we stepped into the new one. This is what's powering the RAM team right now. We changed our cloud endpoints to using AWS, and here is AWS Crosswalk in its entirety. So we've changed that endpoint.get to a more full-featured expressive API, so we can express our routes. We can inline without having to have these dependencies as part of our project. We can inline the AWS SDKs. We can express the same scan with a callback, send it all down. We get the same magic functions as we had before. So this, again, it's just more expressive. We don't have to manage each of the individual stages. It's just all done for us. We still keep our Kinesis. We switched over to IoT because we really wanted to they have multiple phones out on the course. So we want to be able to just quickly allow them to connect securely and push data in. It's also a little bit easier to manage. You can see we've reduced the amount of code here a little bit. And then we've come down, we've taken that external function, we've brought it in line. And this is really great because it keeps everything together. I'm all for separation of concerns, but if I'm writing JavaScript, I'd like to keep it all in one place and then slice it up into slice up my project as I see fit, as opposed to being required to have something externally. So we'll come down to our Lambda. So the Mapbox stream processor, right now we're just capturing all of this data from Kinesis, and we are bringing, for the first time, we have elevation profiles externally, but this is high resolution DEM-based elevation data based on the actual latitude and longitude. So we've packaged up this template. We're using the Mapbox an elevation query package written by our data services team to pick up and process this information so we can pass really accurate information to our statisticians. I'm going to focus on this line really quick. You can see this is standard Dynamo connection, but instead of having to remember what the asset table is, or the ID or whatever, I just go grab it. So this is asset table ID.get. So I don't have to worry about this. I can focus on my problem, which is parsing this data and making sure Dynamo stays up to date. We've got TTL in here. We've got all these different pieces. We're able to pass in Dynamo, pass in Firehose for archival, and set it all up. this is a great way, like this function here, where we go. So right now we're firing this elevation query. We can do this for map matching. We can do this for geocoding. We can do this for geofencing, all at scale. So as fast as you can ingest this data, Mapbox can process it and enrich that location information so you can get on with your business. So this is, it's actually much shorter. It's much more expressive, but let's see it in action. So we have this code. It's great and fantastic. But if we want to deploy it, all we have to do is do Pulumi up. And what will happen is it's going to look through our stack, and it's going to start figuring, okay, what do I need to create? And then from here, I can say yes or no. So this is running on my personal AWS account. So I hit yes. It's got a stack of staging. So I can have multiple stacks running, one for each customer, one for each use case. And it's just going to start building these things out. From here, it's really great. We can see all of this running kind of like a, like a cooking show. When it's done, you're going to see this. Here's the stack. Here's all of my resources. This is all great to see, but this is real. Like this is all the pieces, these dependency management, so I can understand what's going on where, and keep track of it all in a really easy to use thing. So that's the tech. That we've looked at it. Let's actually see it in real life. So if you go to ram.davehazy.com, you can learn more about Dave and his race. That's him right there. And as we go through, we can see on this this map provided by Mapbox. This is the route. You can see all of the different check stations. Let's zoom in on Dave right now, because he's an elite athlete going on a single ride. We are. He started a little bit later, so that whole pack is in the back, and I think at the moment he is leading. We're in really close. This is the Mapbox satellite layer, so we have a really high resolution image, and that's him. And this is data currently provided by track leaders, because I said our watch that provided this lat long has failed at the moment. We don't know why, but we've actually our fix is in deployment now. So later today we should have real time every 5 seconds of data being shown here. There's also another view that shows all of his stats over time. Right now his heart rate's at 120 beats per minute, and his core temp is 99.6. For those of you who don't ride bikes, or who this is a pretty amazing stat here. He's running at pretty normal beats per minute and a really standard body temperature in the middle of the desert on the third day of riding after sleeping for 2 hours yesterday. So he's literally an elite. This is an elite performance that we're supporting here. So it's pretty crazy. So you're welcome to come visit the site. Our partners here, Click, have created a great historical analysis, so you can see kind of who else has done it. And with that, that's it. I'll stop sharing here. We'll come back to the presentation just to close things out. But we've covered everything from what is asset tracking and how do we apply it and how do we scale it. We've talked about best practices. We've talked about how we can deploy these things systematically and using our favorite type of programming languages. We've brought it back home to a real use case that's tangible. It's not just like Uber Eats delivering cookies at 11 p.m. Not that I've ever done that. But that's where we are. We'd love to take questions, talk more about Mapbox, Pulumi, or serverless. So with that, we'll get into it. So the first question is actually for Cameron. So can you talk a little more about the AWS services that are supported?
Yeah, so Pulumi has very broad support of services across Amazon, again, other providers as well, and really it includes all the major and even perhaps less commonly known services from Amazon as well. So of course, VPC, EC2, S3. RDS, Kinesis, DynamoDB, really, the vast majority of services are within Pulumi. And this specifically around Crosswalk is, again, where we provide best practices around VPC configurations, API Gateway is a really great use case for Crosswalk because it helps, again, build those integrations of Lambda to API Gateway and such. And then ECS, EKS clusters, and so on are within Crosswalk.
Thanks. And then we have a follow-up on that. Is Pulumi Crosswalk for AWS, is it free to use? How do you, can people just get started with it today?
Yep. So the Pulumi command line, as well as all the SDKs and libraries we have, are all open source and free to use. That includes the Crosswalk libraries. So the AWS X and EKS packages that are a part of Crosswalk are open source and free to use.
Cool. Everyone loves open source is the way to go. We all love being able to collaborate. We've got a couple other questions. One, we'll pass this one over to Trevor just to quickly get started. So can you, in a couple sentences, what's the fastest, maybe most efficient way to get started with serverless today on AWS?
Yeah, so I think the fastest way is get your hands dirty. I think the only way you can really see the benefits and experience this is to actually stand up a serverless application yourself. So where it be going to use the AWS SAM application model, the serverless application model that has the CLI, you can go find a good couple of examples out there, or using partner tooling that allows you to stand up these applications. I think the best way is actually just start somewhere and start by actually going to use Pulumi, go and try out this new functionality that they have. Go and stand up an example. They spend a lot of time to make sure that you see the benefits of this, and then really start looking at how you can start transitioning application workloads across to serverless if they fit. But I think the best part is essentially, you can read as much as you want, you can watch as many webinars, attend as many workshops, but once you actually start standing this up yourself and you start seeing how fast it is and how quickly you can move, that's when it really starts, you start seeing the benefits of it.
Great. That's actually how I got started, just I actually created a little helper app to keep my life organized. I just have a Slack command that keeps it to do, updates and a GitHub issue in a GitHub repository, and then it yells at me every day for the stuff I didn't get done. So it's just finding a great use case and something that's meaningful is a great way to get started. So thanks, Trevor. The next couple here are more focused on Mapbox and this actual example. So the first one, the code, there's a question like the code showed be available to attendees. Unfortunately, we won't share the entire code base. There's a couple of examples on the Mapbox blog as well as on Pulumi to showcase some of the ingestion and consumption APIs. Part of that is because this is meant to be a flexible architecture. If this is something that you feel you need, where Mapbox is happy to help, you can just contact us or you can get in touch with me directly. We'd love to talk about your use case and help. If you want to test this out, we'll spin it up for you and it takes 10 minutes. But because we're still iterating on this is a beta product. It's not even a lowercase p product. This solution is something we won't release quite yet, but we're more than happy to help you get hands-on with it. The next couple of questions are around integration, and Trevor, I'll ask a piece of this to you. So the sensors themselves are integrated through an Android app. So we have the watch, we have the equivocal sensor, we have something called Human. Those all are collected through an Android app running the IoT SDK for Java, and it collects that information and fires it to IoT. So Trevor, for those of the people who aren't familiar with kind of the SDK side of AWS, could you touch on that for a second?
Yeah, definitely. So starting off, each of AWS services, if you have interacted with them in some capacity, it's all API driven. And we really want to make sure that, it's complemented with a whole bunch of SDKs. So if you're going to be doing things, we have abstract services that allow you to build applications, like, for example, a mobile app that you want to be able to interact with AWS services. There is a fair amount of really good examples out there. I'm happy if you guys have any particular use cases, you're welcome to reach out to me. But you really want to look at how you can be able to connect it to a secure endpoint, where it be if it's doing something via WebSocket or if it's an IoT endpoint that you want to be able to connect to. We have, a lot of teams working very passionately to make these functionalities and workloads, be able to connect to AWS and provide that consistent experience. So I think once you get your hands dirty with a couple of these services, you start interacting with the APIs and playing with their SDKs. But if you do have any deeper questions or particular workloads that you want to understand how to run or interact, or sort of integrate with AWS services or partner tooling in some capacity, there's a lot of solution architects out there, including myself, that are willing to work with you and understand those sort of workloads, the use cases, and what are the best sort of architectures and integrations that we recommend. We want to make sure that you're doing the right thing there and you're not stuck with an application that's maybe not designed to scale to meet what sort of your business goals over the next couple of years could be.
Great. Now, the follow-up question for that was for our team, saying, where does this code live and who defined the APIs? The code lives, it's in a GitHub repo designed by, it's actually a student part of this team. The APIs were all, we basically used the Pulumi package to define the IoT endpoints. We pulled the account-specific endpoint and we provided them a channel, and then they provided us with the data schema. And we aligned the processing functionality with that. So it was a team partnership. We have a shared schema, and then or a shared JSON structure that we pass through as well as enrich. So that's kind of how the integration happens. It's all done through the Android app and IoT core. Next question. This process of how it was scaffolded out, use the local dev server or go straight to serverless. Actually, we started with the console, point and click. We just wanted to validate that all of these pieces worked. How getting AWS can be intimidating. I know that was my experience to get started. What's an IAM role? Why does everything go through IAM? What is Kinesis? What does it do? What is Lambda? What does it do? So we started with console-based stuff and Postman, firing APIs requests to the endpoints we created. We started moving over to IoT. We have a little local testing JavaScript harness. And as we built that out and the app became more real, we started using that for testing. And then because Pulumi was so easy, it's very easy to deploy and test in a development environment. We didn't have to do much local testing. Also, the processing was somewhat straightforward. So we didn't have to worry too much about contacting other services other than just direct push. But then once we were done, it's all packaged up as a serverless application. So it made it pretty easy. I think we have time for one more. This is a Mapbox specific question around the max number of nodes Mapbox can handle, i.e. can it show every Amazon delivery in the US at the same time? The answer is yes. Vector tile technology is incredibly efficient. We have examples of billions of points on a map. We have every geocoded tweet over the course of, I think, a couple of weeks onto a map that's 6.5 billion. We have a dot. We have a map showing a dot for every single person in the U.S. Census. Basically, your data volume we can handle. If you want zip +4, we can render that. If you want to show things live updating, we have processing technology to help with that. A lot of time, if you are processing big GeoJSON payloads, the problem tends to be more I/O than our processing. So we can handle the scale of your data volume. If you have questions or want to give it a shot, get in touch. We'll happily walk through whatever use case or data scale you have. But we haven't yet found a data volume we couldn't handle. So we'll leave it at that. And at that, we are at noon. I think that I don't see any other questions in the queue. I wanted to thank everybody for coming. Thanks to Trevor and to Cameron for contributing their expertise, as well as building wonderful technology. Thanks to everyone who joined. We are going to share this out. This is a recording. If you have any questions, you can find us on Twitter. You can come with us, come talk to us through our corporate websites or reach out directly. If you have follow-up questions, we're more than happy to help. But just in closing, we wanted to bring it back to, this is a problem that a lot of companies have. Working with these best practices at scale, really with these types of modern technologies, really allows us to focus on business outcomes rather than individual tooling decisions, because they take some of that lift away. So these things are possible to build. They're able to be built scalably, and you don't have to have a fleet of trucks to really make use of location data. If you have it, combining these technologies end to end and using things like using the Mapbox platform with Pulumi and with AWS is a really great way to actualize business outcomes or help somebody complete a feat of human strength and reach the finish line faster. There's a couple of questions that just came in. If you need to, quickly, these are very not technical. Contact to discuss our use case. If it's geospatial, you can get in touch with us at Mapbox. If it's tooling, I would say get in touch with Cameron at Pulumi. And if you have a very specific question about AWS services, you can get in touch with Trevor. And in the email, we will send out contact information and making sure that everyone has the right people to contact. And in terms of estimated costs associated with this particular data stream, I think based on our modeling, I think it's cheap. I don't want to put a specific dollar figure on it, but it's cheap. It's in the tens of dollars because it's all pay per request versus the hundreds of dollars. So just the infrastructure alone is not super expensive, but we're also at the smallest possible. We're running once every 5 seconds on a very, very tiny Kinesis stream. So, we're happy to talk about modeling that cost for your use cases as well. So with that, I will leave it to leave everybody. Hope they have a great day wherever you are, and look forward to speaking with you about your use cases and check out Dave's race when you have a moment. The team would love to get more followers and have more people eyes on this fantastic race. So thanks everybody. Thanks Trevor. Thanks Cameron.